This is Geometry B, Unit 3, Lesson 1, Ratios and Proportions. A lot of algebra in this, a lot of stuff that you learned previously in middle school. But it's necessary because we're talking about similar polygons and similar shapes, and that involves writing and solving proportions. So a ratio. We talk about ratios in a lot of ways. So, for example, a ratio of a class might be girls to boys. So girls to boys, right? Okay, we can express that with the word to. We can express that with a colon, girls, colon, boys. Or we can express it as a fraction, girls divided by boys. Okay, so let's say the ratio of girls to boys is 3 to 2. 3 colon 2, okay, and 3 over 2. All equivalent ways to write the same ratio. We can write and solve a proportion for a given problem. The ratio of girls to boys is 3 to 2. A class has 9 girls. Okay, how many boys are there? So I might take this. I might take the ratio of girls to boys as 3 to 2. And I might take the 9 girls to X boys. Okay? And I can write and solve proportions from this. I can write and solve a proportion this way. I can divide straight down. 3 is to 9 as 2 is to X. I could also do it this way. I could say 3 is to 2 going from left to right as 9 is to X. Okay? And there are lots of ways to write this, but really it comes down to solving it the same way. We cross multiply and divide. All right? So cross multiply. 3x equals 2 times 9, 18. And then divide by 3. Okay? Cross multiplying and dividing is the preferred technique because it always works. Okay? 18 divided by 3 is 6. All right? However, there's other ways to do it as well. I might note, for example, that 3 times 3 is 9. So 2 times 3 is 6. Right? And so I could actually find it that way as well if I have a common multiplier. Right? Lots of ways to write and solve proportions. But ratios can be written with the word to, with a colon, or a divide. Now, you need to be able to solve proportions. A proportion is a ratio is 2 ratios set equal to each other. You need to be able to solve proportions with x's involved. So let's say, for example, I've got x plus 7 divided by 4 equals x minus 3 divided by 15. Okay. In which case I can solve by cross multiplying. Solve by cross multiplying. 15 times x plus 7 equals 4 times x minus 3. In this case, I need to distribute the 15 by multiplying. Distribute the 15 by multiplying. 15x. 15 times 7 is 70 and 35, 105. 4 times x is 4x, and 4 times 3 is 12. Okay. I might subtract 4x from both sides, because I've got an x on both sides. And I'm going to do this in one step, so I'm going to subtract 105 from both sides. And we end up with 15x minus 4x is 11x. 4x minus 4x is nothing. Negative 12 and negative 105 is negative 117. And then divide by 11. Okay. Now this one didn't turn out really nice because I just made up the numbers off the top of my head. But we get x equals negative 117 elevenths. Or you could rewrite that as a mixed number as 10 and 7 elevenths, negative. Okay. or about 10.7 to the nearest tenths. Right? So, but the idea of cross multiplying and dividing. Okay? The product of the means is the product of the extremes. You're going to hear that here. Okay? So these, the downward diagonal is called the extremes. Extremes. And the product of the upward diagonal is called the means. The means, the product of the means equals the product of the extremes. So, for example, if I had A to B equals B to C, the product of the means equals C to D, equals C to D. The product of the means would be, B and C. And the extremes are the outside, would be A and D. So the means and the extremes, kind of like that. So that's a little bit of the vocabulary involved. Now there's one kind of problem that may give you fits, so I want to do that here. Let's say I have this problem here. It says the circumference, or the perimeter, of a triangle is 800. The ratio of sides is 2 to 5 to 6. 2 to 5 to 6. Got to make sure that works. You can't have any two sides add up to more than the third side, otherwise that wouldn't work. All right? So here's one way to solve that, right? You can multiply any number you like by a constant. So for example, let's say I have the fraction 2/3. If I multiply top and bottom by 3, that equals 6/9. 6/9 and 2/3 are the same fraction. Reduce 6/9 and you get 2/3. And that's the same for a ratio, right? So if I have a ratio of 2 to 3, that's the same as the ratio of 2 times 3 to 3 times 3. You can multiply any factor you want by all the terms, and the ratio remains the same. So let's do this. Let's multiply all 3 by some number a. So 2a to 5a to 6a. And the perimeter is 800. So the perimeter is found by adding 2a plus 5a plus 6a is 800. And that gives me an equation I can solve. So 6 and 5 is 11, and 12 is 13a. Okay, so a is 800/13. And I'm just going to leave it like that. Again, I made up the numbers so they don't divide nice and even. It probably will with the problems you're given. But a is approximately, 70 or so. All right, yeah. All right, so now, so that tells me what a is, and then to find each of the sides, you plug that back in. 2a is 2 times 800/13, which is 1600/13. And 5a, give me the other side, is 5 times 800/13, which is 4,000. 5 times 8 is 40/13. And 6a is 6 times 800/13. 6 times 8 is 48, so 4800/13. Okay, let's get some real regular numbers instead of improper fractions here. Bring up Desmos. Nope, I don't have Desmos open, apparently. I thought I did. Desmos.com. Just to do these here. Okay, 1600 divided by 13. 123.1. 4,000 divided by 13. 307.7. And 4,800 divided by 13 is 369.2. I must have hit full screen. 369.2. Okay, so that's kind of how to do that particular problem. Hopefully that helps.